Continuing on with our types of displays, next up we have the line graph. So the line graph is another helpful display for viewing individual data values within a small numerical data set. So we've got our stem plot, which is for numerical data. We also have our line graph, which is for numerical data. So in a line graph, the x-axis, that bottom horizontal axis, consists of our possible data values, and the y-axis consists of the frequency there. And then the frequency points are connected to form this line. So example 2, building a line graph off of some data. Following data shows the number of classes students take from a random sample of TCC students. Create the corresponding line graph. So I wouldn't want to use a stem plot for this data because they would all have the same stem. I can think about a 0 in the 10 spot, and then I would have all of these different numbers. So by making a stem plot of this, I'm just ordering them from smallest to largest. So I could put this into a line graph. So along the bottom, I will put my possible data value. So I can see the lowest value that I have is a 1. Then I'll walk my way up to a 2, then a 3, 4, 5, and then 6 is the largest number in the data set. So these are my number of classes that students are taking. So we're taking 2 classes or 5 classes or 3 classes. And along the side, on my vertical axis, my y-axis, I'll put my frequency. So did I have 1 person taking this number of classes, or did I have 2 people, or 3, so on? I'll go a little bit off the graph here. So that's 8 there. And we'll just go through and count the frequency. So if I look at my data, I've got 2 1s, a 1 here and a 1 here. So I'll put a dot to begin with up here above the 1 at a frequency of 2. There were 2 1s. Then I'll see, well, how many 2s did I have in the data set? I had 1 2 here and a second 2 here. So 2 also has a height of 2. Then for my 3s, this appears to be the most prevalent number. So I've got 1, 2, 3, 4, 5, 6, 7, 8 3. So 3 will go up to the very top here, frequency of 8. Then I'll move to my 4s. I've got 1, 2, 3, 4, 5, 6, 7 4s. So just a little bit shorter than that 3. For my 5s, I see 1, 2, 3 5s, and then 1 6. And that marks all of my data. And now I'll just connect these with a line. So connecting those to those. Oh, sorry. Missed a dot there. So 2 was here, then 3 was up here at 8, then 7, then 3 for the 5, and then 1 for the 6. So again, I can just see, my range, what's typical, range from 1 class to 6 classes on the low to high end. Most students are taking 3 or 4 classes. Those have the highest frequencies, although some students take 1 or 2 classes, others take 5 or 6. Extending from the line graph, I can move down to the dot plot. Dot plots are another type of graph that can display small numerical data sets. So we're just building our repertoire here. Dot plots for small numerical data, just like the line graph, just like the stem plot. Everything has been for numerical data so far. Each individual data point is represented by a dot above the corresponding value. So if you have 10 data pieces, you should have 10 dots on your dot plot. If you have 25 data pieces, you should have 25 dots on your dot plot. So to create a dot plot from the line graph data from above, what we would do is first off put our values once again across the x-axis, that horizontal axis. So 1 class, 2 classes, 3 classes, all the way up to 6 classes. And this is the number of classes along the bottom. And then I had 2 students taking one class. So I'd put one dot above the one and then stack right on top of that a second dot. So those 2 dots are representing my 2 students taking taking one class. Then I had 2 students taking 2 classes. So again, another 2 dots above that. Then 3 classes, the most common number. There were 8 threes in the data set above. So I'm going to stack 8 dots on top of one. So there's 2, 3, 4, 5, 6, 7, 8. There were 7 students taking 4 classes. 7 dots. 3 students taking 5 classes, and 1 student taking 6 classes. So we can see a similar shape to our line graph. 3 classes, 4 classes, the most common, ranging from 1 to 6 on the high end to the low end. So thus far for small numerical data sets, we have the dot plot, the line graph, and the stem plot.